just give you a quick overview about this native AI and cross-domain AI. That's two AI topics we will now focus. So AI is so popular that everywhere, and so a lot of research has been done, a lot of proposals has been done. So for the ORAN itself is already have the AI and the studies, and also in the working group, and trying to also bring into the specification. But in general, this AI on the architecture point of view, and how this AI should be integrated, and what kind of impact also to support AI, the data and the interface, all these kind of things are still open. So we trying to identify these two topics, that is native AI, how to provide AI integrated into network, and also close-domain AI. That's also even important, because there's so many AIs, and which AI is more strong, which AI should connect, is really need to be studied. So for that, first the questions we ask, and is that so what is the definition of native AI and cross-domain AI? And for this is we have a research stream that deal with these topics, and for this research stream, as I introduced also in previous overview slides, we have these 4 co-leaders and to deal with this, and also we have also many members and in this research stream, and one of the most active research stream in this group, since this topic is very important also for the future. Okay, so here we take some so this work has been started for around 4 months, and take really some time to discuss and debate and think what is these 2 definitions, because that definitions define the scope and how we deal with this work. So for the native AI and cross-domain AI, so at this moment we have reached a certain consensus on the definition, but of course this definition may evolve. At least we think native AI is something that is AI to support the functionality in the network, and also the network include the functions and the nodes, and also this endpoint and also interface are all a factor to support this AI, and also AI to support the functions inside the network. So let's to put it all together. This will also need a network architecture to support it. So it's basically how AI embedded into the network architecture node or endpoint, and to support those functions there. So that's our definition for native AI. And for the cross-domain AI, so the key question is here is what is the cross-domain? So this kind of is this kind of integrations or cooperation or AI different domains to work together. So far we agree that for the scope we focus on the domain, at least for the communication network, on the radio access network, and the call network, and the transport network. And also we think about also the go beyond that, this application domain. It's also should link also with this network domain. And also there's also digital twin that is also coming up and very play important role, and that's those digital twins should be also connected. And of course we are not limited to those domain. For instance, other domain like computation, like cloud. And this is also important, right? Because if we put cloudifications and how to link this together, and compute resource and how to combine and use AI to coordinate AI in the cloud resource and AI in the network, radio network resource, and that's also need some considerations to put this together on the AI side at least. Okay, so with this definition, so we first identify this AI and in the current network. So certainly the AI already started in the 3GPP, like this run 1 and run 3 have ongoing work on the AI, and so there are many work ongoing, and especially for all run, I will also have 1 slide to give you an overview of the AI in all run. So we also actively to put AI in the current our own architecture. So there's approach there, but of course as we believe that 6G that will be empowered by AI, and they need really some fundamental changes that to include AI, and also this coordinate or orchestrate AI functions. So this is a really open questions to how to really realize this kind of say AI dreams in 6G, right? So that's why we have this specific research stream to deal with that. So you see that for 6G AI, at least they deal with this physical layer and resource allocations and the sensing and all the spectrum. So the key question is that if you have so many AIs, and how to manage it? In which way you implement AI? You implement AI in individual component, or you have a platform approach to deal with AI. So the platform approach can be the AI in the cloud and then integrate with the communication system. So there are many options. So that's the way we trying to also investigate for that. And for the all-run, you see the architecture for all-run, especially the RIC extension that to control or coordinate the radio network. Already the AI there, right, in the low layers DU, and also for the RIC, they have this real-time RIC, the AI there to support the functions, and especially on top of the real-time RIC, they have a long real-time RIC. The AI framework introduced in all-run actually happened a lot in that long real-time RIC level, that is this kind of SMO level, management plan level. So if you see in the working group 2, we deal with long real-time RIC, this kind of orchestration aspect, and they already proposed AI workflow there. So here is some ideas there. So in that level, we introduce this kind of AI platform, and we do the training, all the training in that place, and the data collected from the RIC and the interface to there, and can build up the model and also the training there, and then the model can store in some place on the non-real-time RIC level, and then after you can distribute that, push that back to the different components in the network in the real-time RIC or in the DU. And also there are some consideration to put even in no layer that you have one place to train and to share the platform and easy to manage those AI topics. So that's what happens there in all-run. So now, but this is hard to say, is already native AI based, right? So now we're trying to see what really could be make it as AI native based, but it's still, the question is still open, and we still need time to investigate that problem. So in general, you see that for AI that will be included in the RON domain. This cross domain AI here is shown. So the RON and the core network and the application, and also in the transport network domain, they have also the AI. But beyond that, as I mentioned, this cloud domain, that computations also the domain. So how to put this AI together? So what kind of best approach to combine this together is the key questions that in this in our this nGRG group. So of course that's key challenge. What kind of data? How to get the data from the network, and especially when you have different function to support AI. So the data, the amount of data are different, right? So real time you have very lot of data to make decisions, and you have to make it close to the AI, close to the component, and also management, and this also you have to manage to whole network and collect different data there. So data is a challenge, how to collect data and how to define interface there, and in which way that you can, if you use this current all-run solutions, this platform approach, and how to integrate with the, how to say, the network, and especially for 6G, we want to have one standard, right? So, but how to integrate that into one standard is all these open questions. But in addition to that, for the AI itself, and also the general research questions, that especially for the run part, because this is that previously you make optimizations, you make precise decisions and optimization. But now if you use AI, and how to assure that AI do the job, that the AI most cases they do the job, but if they don't do the job and they make some kind of decisions that against this results, and then how we can make sure that not happen, right? And also for the communication networks, there are a lot of privacy issues to deal with. If you use, because the key for AI is the data, right? Is actually how data flow from different places and then utilize data and then can get insight and then you can feedback and take actions from the data. But how the privacy should be protected is also key things to deal with this 6G network. And for complexity is certainly that's one thing very obvious, and you have to avoid that you have a lot of AI together and you don't create a system human cannot understand and manage it. Right? That's also the key things need to be think about in these AI solutions. But the most important, of course, is that testability. That you have to make sure you are put this AI into a black box and how you can explain the behavior of AI, and also that can repeat the test instead of you put everything there and you have magic and come out and then you assume everything is perfect. That's maybe not the case, and certainly they need a way to also to make it possible to verify all those results. And then for this native AI and the cross-domain AI, so we are focused on two aspects, right? One is this architectural side, how to support these two native AI and cross-domain AI, and then second is that we deal with different research problems and for this how to integrate these two native AI and cross-domain AI together, right? So I just listed some kind of aspect in the current release research stream and work and the ongoing work. And so currently the main work we are dealing with is the technical requirement on the native AI. So that and we so for that part, so we first of all we try to identify this kind of AI, this life cycle management. And for this one, we use the platform approach because in Oran they already use this kind of platform approach that has a framework and defined, as you show in previous slides, that have the platform and one place to train AI algorithms. So there are different, of course, AI algorithms that this kind of deep learning or this kind of reinforcement learning, and different algorithms they need to have different life cycle management, and also when AI applied to the different components like some DU and RU, the time requirement is different, right? So for this we have different way to push the AI and manage the AI. So this different life cycle management. So we investigate what kind of requirement there, and also for AI, this is about the data and how to requirement for the data in different places of network, and also how to put the computation powers and to support these AI functions and what kind of potential impact to the architecture. That's one important thing to deal with. So we at least this stage we are focused our effort on this aspect. So, but for the long term, of course, we deal with this native AI and the cross-domain AI, and so in a more general way to 6G. So go beyond this technical requirement, and we will deal with how to really AI and for architecture, and how to, if we need a native AI architecture, what change and what kind of requirement needed. So that's one next important topic that we will deal with. But this one, we will cooperate also with the architectural teams, and we have a research stream mainly focused on architecture. We are cooperating with that and to deal with this topic. So I think next, Havish, you will introduce that part of it. Let's hand over the floor to Havish.
Okay, thanks, Tao. So So we have three more topics here to go through, but just to give some time for our panel and have some interactive discussion, I'll try to go through these a little bit quickly. So when it comes to the security research stream as well, we have three co-leaders, and as always, we are trying to keep a balance between different types of companies. The main thing I would focus here is basically on the scope of what we do. So first of all, we need to survey what is happening in all of these other regions, in terms of the security aspects that are being highlighted as being important for 6G. One key activity is to then maintain a threat analysis that eventually we hope will make it into a white paper that we'll publish. And generally, where applicable, whatever are the technological solutions, those are some things that we need to identify as this research work goes on. And of course, a key aspect is security kind of permeates through, it has to permeate if you want to do it right, through everything that you're doing within the nGRG and beyond. So collaboration with the other research streams is crucial here. I would highlight the key challenges in 6G when it comes to security are that if we have new architectures and services, then in general, a threat analysis of what are the security implications is absolutely essential. So that is something that needs to be focused on. Also, the adoption of AI/ML techniques quite widely creates new security threats. Generally, moving to cloud-native, distributed microservice architectures, these also will make it more complicated to establish trust. And then user and data privacy become quite big concerns with any kind of data-driven architecture, where data is at the heart of how we make decisions. So, and then finally, one of the things that's also come up in the security research stream is about the effects of quantum computing in the future on how it will impact cryptography and the threats that it poses. So I'll skip over the research directions here and focus on the key things that are being worked on right now. So first is the security threat landscape. So there is an activity inside this research stream to try to compile what are the key aspects that we need to be aware of, including distributed trust and cloud native security in a cloud native domain and so on. Another activity is basically around these quantum resistant cryptographic algorithms on how quantum computing affects post quantum cryptography and aspects like that. And then the final aspect here that we are focusing on for the moment is privacy preserving computation. So homomorphic encryption, where we can do computations without while preserving the privacy of the underlying data. So once again, collaboration with SDOs and open source is something that will be running in parallel under all of this. So with that, let me switch to the architecture part of 6G networks. And one thing I would, and again here, this just shows you the companies that are involved with leading this effort at the moment. So once again, we hope to have a balance between operators and vendors. And when it comes to the scope of the architecture, so one underlying thing about architecture here is that the architecture, as we know with anything, product architecture, ecosystem architecture, supply chain architecture, whatever, it impacts everything. So we have the understanding that the architecture especially needs to be quite wide open for now. For this research stream, it's not possible, especially this early in the game for 6G, to make any big decisions on it. But at the same time, it has to take into account things that are being done on the use case front, on aspects related to AI/ML, on aspects related to security, and so on. But one key activity that we are pushing in this research stream is how to make a cloud-friendly future 6G RAN architecture. So that is the key aspect. I'll go through a little bit quickly over these research questions. So as you can see, since it's only been about 4 months since we started this group, and also, as you know, 6G is still quite far away. But at the same time, we expect the standardization process to start, in a couple of years or so. So we are at the phase right now where we are making sure that we ask the right questions. It's not so much about having solutions at this point. And as we all know, asking the right questions is really important. So that is a key part of the activity and the theme that you will see through each of these. So I won't go through these in detail, except that, just that there are some aspects. For example, how do we decouple the business logic from the platform that they run on? I think these are also important aspects, especially in the O-RAN Alliance, for us to look for. And how does the architecture support network intelligence? Energy efficiency is an aspect here. And another thing I would highlight is how does what we do in O-RAN here be integrated into the end-to-end network, with all of the service orchestration and automation aspects, right? And what are also the impacts on current hardware? So these are some initial questions that are being posed. And then when it comes to this cloud-friendly future 6G RAN architecture, there are some specific research questions that we are focusing on. One of these, for example, is decoupling this nGRG architecture functions from the platform itself so that we can have maximum flexibility for various types of deployments that we will need to support. One more thing I would, so this is all part of this cloud-friendly aspect. I mean, and the key part here I would say is really how do we maintain maximum flexibility in the architecture itself. So with these, one thing I would highlight with the additional topics here under discussion is that how do we also let implementation and deployments inform us to what we do with standardization. So that's what the diagram here is basically trying to show. But with that, with architecture, let me switch over to Ian from Viavi Solutions. He will talk about next generation research platforms, and we will get to the panel as soon as he's done. Thanks.
Thank you, Havish. So as mentioned, my name is Ian. I work for Viavi Solutions, and I'm also co-chair of the research platforms research stream in nGRG. So these are the co-leaders, Nirlay Kundu from Verizon, Balaji Raghutaman from Keysight, Tracy from AT&T, and myself from Viavi. So really the motivation here is, as we progress, right now from 5G to 6G, as you all know, as we transition from one generation to another, prototypes and test beds are critical, right? Improving out the viability of new ideas. If you can't prove it, if you can't test it, it's really not going to be impactful. So basically, 5G O-RAN Alliance, we have this mission of reshaping the RAN to be more intelligent, open, virtualized, interoperable. We see that as key ingredients as well, of course, as we move into 6G. In fact, we have a great opportunity to imbue these, these tenets, into the design of the 6G networks from the ground up. And that means O-RAN Alliance needs to engage with the researchers today so that that actually, becomes a reality. So as an example of research platforms, in the run-up to 5G, there's already a lot of, test bed. It's kind of exploded, I would say, during the 5G era. An example here is in the US. I don't know how many of you have heard of the Platforms for Advanced Wireless Research. This is a program funded by the National Science Foundation in the United States. Really, government, funding a lot of the large-scale infrastructure, I would call research infrastructure. The goal is to get city-scale test beds all around the country in the U.S. And allowing researchers to have access to these and freely sharing the results and have actually direct connections between these test beds. So these are the examples of the test beds that are running today. Almost all of these are running today except for the Iowa State one. ARA is focused on agriculture kind of applications. And this is a great example of research platforms. And we want to see, clearly there's also a lot of this in Europe and in Asia. And part of the goal of this research group is to collect, understand where things are, do a survey, and then try to understand whether, what are the gaps, what are missing pieces so that these next generation topics like, native AI, native cloud, like what do these platforms need to have so that it's actually better suited for these types of research questions. So kind of summarizing, we want to explore the requirements for the evaluation of these concepts. A big part of this is influence, right? As you know, of course, O-RAN Alliance is primarily, it's a lot of industry players, some academic players. We want to influence these research platforms in both industry and academia, and also government funding agencies, so that we can prioritize concepts like openness and virtualization into these test beds. And scope of this work right now, we're working hard on a survey of the existing global public-private NextG testbed efforts. We want to reach out way beyond O-RAN. We're probably going to leverage, organizations like IEEE to really understand the research platforms landscape today. We want to foster the creation of, we call them open RAN testbeds, right? Utilizing concepts like open source, cloud, to really make it much more accessible to a broader, research community. And you can read the other things. I do want to highlight our open source community within the ORAN Alliance. That is a very unique aspect of I would say, any alliance. We're actually collaborating with the Linux Foundation. I want to make sure that research platforms out there utilize what's being done in the OSC for their research efforts. And finally, when we get to that point, maybe 5 years down the road, standardization is well underway. The group that I also co-chair in ORAN is the Test Integration Focus Group. We want to make sure that we're prepared on the TIFG side and OTICs, Open Test Integration Centers, to actually take these concepts into the next step, which is, of course, validating commercial equipment when we get to that point. Maybe, I don't know, 5, 6, 8 years down the line, who knows. All right, that's it from my side. Havish, back to you.
Okay, thanks, Ian. So I think with that, we can get started with the panel that we have. So in the panel, I would like to invite Tao and Ian, who you heard speak, as well as Jiajin from CMCC, who's been kind of involved from this at the very start, I think, and was instrumental in getting the nGRG started. So Jiajin, if you... I mean, if it's okay with my fellow panelists, we've been talking at you for a long time. So I have some questions in mind that I would like to ask the panelists, but if you have any questions, just please raise your hand, and then I can intersperse your questions also with the discussion that we're having here. So, yeah. Okay, so maybe to get started, at least I could ask, maybe the panelists to provide some perspective on. We have provided a lot of overview, right? We have started the nGRG. We have done all of this. But I think one question, if I was in the audience, for myself would be, yes, we understand all of this, but why do we need to do 6G, this kind of thing in the ORAN Alliance? I mean, it's already being done in many different forums. So what is the need to do this in ORAN Alliance right now? So I think it would be good if each of you could provide your perspective on that question.
Okay, so let me start first. First of all, if you see that ORAN proposed this architectural extension to 3GPP and provide new possibilities. So you see that a RIC platform and also codification RIC platform, so it's moving in the way that is to open and to bring intelligence. So, but we cannot stop here, right? Because if you see the industry movement and this cloudification, they try to move this application or infrastructure to the cloud, and so how we can go beyond that, and so for especially for ORAN, since we already take steps to move and this intelligence into the network and find a way to use this RIC architecture and already bring a lot of innovations like these apps, this kind of control application called apps approach there. So it matches perfectly how to move into next step to the how to say, to move more to the cloud and also to integrate things also with other application in the cloud. But this kind of things is, how to say, currently not covered by the ORAN architecture. So but how we can do that? How we can convert at the earlier stage and some directions and to capture all these key topics that are relevant to our own architecture and to promote further. So that's the excellent moment for us to establish this research group, and we can deal with already these topics and have discussions in the industry about this property inside ORAN or even outside ORAN, and to investigate. So in this case, we can, in the earlier stage, we can already achieve some momentum to involve ORAN to the next phase, because always O-RAN need to involve, right? It's in 6G, and we will see what at least when 6G and these key topics like cloudifications and or AI and it's very relevant what O-RAN is doing now, and we want to see what O-RAN can do to fit into this 6G area. So that's some comment.
I mean, I would say, at the end of the day, you all are here, right? And that means you believe in the principles, let's say, of O-RAN and TIP, right? Of open disaggregated, like we have open, virtualized, intelligent, interoperable. But we shouldn't really take it for granted, to be honest, right? Because I think we have all this momentum and we think it will naturally come about. I would say the reason O-RAN Alliance needs to do 6G research is we need to infuse these concepts early on in the research cycle for them to have a good chance of actually being real and baked in when 6G is being developed, right, by the standards organization. So we can't afford not to do it because, again, they don't come naturally. I mean, as you know, this is a change in our industry, pretty radical change to how business and the ecosystem kind of comes together. So I don't think we should take it for granted, and that's why I think we should do the research today.
I'm also the SDFG co-chair of O-RAN Alliance. So through our analysis, I think there are more than 27 organizations involved in the 6G research and standardization activities. So from O-RAN perspective, we think that to engage the academy and the industry to prepare and maintain or to accelerate O-RAN to 6G is very important. And O-RAN needs to more proactively in the next generation, the standardization. And we want to maintain and a unified global standardization, 6G standardization. Okay.
Thanks, Jajan. Yeah, so I think what maybe a key takeaway, what we hear from you is that O-RAN is doing things differently already, right? And it's very important to kind of, especially Tao mentioned the RIC. I think, Ian mentioned all of the trends with the disaggregation and the openness and things like that. And also, I think, Jajan, you mentioned the need for a single global standard and to keep everything together, right? So with all of these dynamics, maybe one question we can ask ourselves is from a 6G perspective or from an end user's perspective. I mean, what are the kind of use cases maybe that 6G will support that will be a little bit different? And for us, especially in O-RAN, I guess a big question is what do we expect those use cases? How do we expect them to impact the architecture and the trends that we are pursuing now? So I'd like to get your thoughts on this in terms of what the use cases might be that are new and how that will impact us and what we need to keep track of. So any thoughts?
So I'll try to take a crack at that and say I don't know. I mean, I'm kind of, I'm an engineer, and I'm kind of the camp of, build it and they will come in a way, right? Like, I know some people will say, that's not the right way to think about it. I mean, I think there are lots of good people out there thinking about use cases, the next generation, holograms with your relatives or whatever. I think, I'm a wireless engineer by heart, and I know how to do, how to improve our networks, how to make it more open, intelligent, again, virtualized, interoperable. I think that's the challenge that I'm much more excited about. And, if we have, we really solve the automation issues, really solve, really imbue intelligence to our networks, then in a way, use cases can be much more easily supported, right? We don't need to do 2 years of standardization just to get, for example, V2X as an application now, right? But if you build up the capabilities of the network to be malleable, intelligent and automated, then the new use case that's going to turn heads and be the next big thing will be much more prepared to kind of go after it. I mean, that's at least my thinking around it. Yeah.
Any other thoughts from the?
From China Mobile's perspective about this question, we had set our vision about 6G, I think 4 years ago, and our vision is about 6G is the ubiquitous intelligence and the digital twin. We think that's the target of our future 6G networks.
Yeah, I don't have specific comment, but for this use case is really, I think, for operator, maybe they have better view. But I think for industry, network and opticals, still, we see the moment that this 5G, but still a lot of things to be done in there. So I think if we find a very key use case for 6G, it should be something there.
Yeah, thanks. I think I appreciated what you said, Ian, about I don't know, because I think obviously none of us can claim to predict the future perfectly. But at least from my perspective, one thought here is that that's a key reason why we have this nGRG, because I think, and it's the same thing with all of these other forums as well. A part of it is that especially when, we cannot tell the future, but things are evolving, and they're evolving fast. And it's so part of the task here is to kind of keep an eye on that evolution, right? And kind of make sure that we are not losing sight of any of the big goals that we are after. So maybe, yeah. So I see a question from the audience. Maybe we can switch and see whether there are any questions we can address from the audience. So, gentleman in the back, I saw your hand first, at least. Yeah. Maybe you can introduce yourself also.
Hey everybody, Mohammed from Dell Technologies here. I have maybe an architecture question. So, like, imagine when O-RAN starts its work. So it's relied a lot on 3GPP specs, and then it just announced a couple of new interfaces. For the nGRG, what I learned is the scope is not just focusing on the interfaces, but many other wider scopes are going to be examined and studied. So how much you think that nGRG will be independent and far from the 3GPP, and how can we imagine to have a new, completely entirely new standard body here without relying on 3GPP, specifically not for beyond 5G. I'm talking mostly about 6G, for example. Thanks.
So I think there's a misunderstanding here is that we see this very broad landscape of research, and you think we will propose something totally different. But actually, that's not the difference. So if you see the mission, actually, the reason to have nGRG is to, at the earliest stage, to synchronize with other standard bodies, and so we go in the same directions. So we are not going to propose architecture in nGRG, because that's not to say, in some sense, it's not our job. So we just to identify these key principles for architecture. For instance, if network go to cloud native, and what kind of key principles will affect architecture, so that we deal with that kind of aspect, and we provide a white paper regarding what is our thinking for that. It's the same for the AI, and so if AI will impact the architecture, we will have some, so our thinking, our findings regarding what kind of support needed from architecture. We provide this input and the tool. Also, we're trying to link this with, since Jiajing is this SDFG, that is standard, and focus group and chair, and they will communicate with 3GPP or other Asia, other standard body, and to synchronize. So that's the way.
So the answer is no. We're not going to develop our own standard apart from 3GPP. I mean, we're obviously creating standards that complement 3GPP architectures. We want nGRG to continue on that path of influencing, right, this, as 3GPP, I know, is a very big, complex body, just like ORAN alliances. Any alliance is like that way, but we need to assert our influence, and people, like-minded companies that believe in the mission, we want to do that. And then, at the end of the day, I think a single global harmonized standard is the best for the industry. Any fragmentation is going to be bad. So I think, at least from my point of view, from Viavi's point of view, we fully believe that that's what we need to do.
Yeah. So our target is unified, the global standardization. So we want to avoid significant incompatibility between ORAN and other SDOs.
Maybe I can just add to it. I think if we look at even the 5G system, or it's not just 3GPP, right? I mean, there are also standards over and above, especially now as we get to more cloud RAN and aspects like this. I mean, there are also CNCF and other areas where if you look at the entire system, I mean, there is an ecosystem that's much beyond only one standards organization, right? So that's one thing I would note. Second thing, yes, I mean, ORAN, in our understanding at least, has been basically complementary to 3GPP at this point. And it's not clear that there is any benefit to kind of abandoning that type of model. Now, so a lot will depend on how much 3GPP adopts a lot of the principles that ORAN has been driving, and but my expectation at least would be there will be a lot of those that will be picked up by 3GPP for the next generation, right? So, yeah.
But also, I think, especially for 6G, since it covers so many domains, right? Maybe one standard body can cover all. That's maybe 3GPP can cover all the topics that. But we have some advantage to investigate all topics together and have some views in advance. Yeah. So that's some good things, I think, for this nGRG.
Maybe I can hand over to the gentleman here.
Yeah, my question was actually almost the same direction. I was wondering, how you're planning to collaborate with 3GPP, but yeah, you mostly answered that already.
Okay. Okay, I see another hand raised in the audience, so let's go to that one.
Sorry, I think my name's Gabriel. I'm an analyst at a firm called Heavy Reading, and I did miss quite a lot of the session, so I apologise. But I don't think you really did answer that question that well, honestly. ORAN Alliance does propose an architecture. That's what it's done. I mean, so saying you're not going to propose an architecture for 6G, surely that's you've got to be putting inputs in, because that's what ORAN Alliance is all about.
Yeah, no.
Just having an input, it's not really enough, right? It's just a talking shop then, or what actually are you going to do that isn't going to be done somewhere else?
Maybe I think, just to clarify, we're not saying we're not coming up with specs, right? We are, right? We're a spec creation body, but the specs that we create are complementary to the 3GPP specs, right? If you look at the 5G spec, open front haul.
Yeah, but that's
right.
Because this has come after the 5G spec. The disaggregation was DU, CU, was as far as they got, and you wanted to go further.
Correct.
That's why there's ORAN Alliance.
That's correct.
From what I can, the obvious thing would be to, as they define the next RAN architecture, that it is based on open principles, but you need to have an input into it and an advisory or something.
Yeah. Maybe I can add to that also. I think, just to be a little bit more precise about this, I think when we say we're not going to develop specifications, we are talking specifically about the nGRG. So the nGRG, which is a subgroup in the ORAN Alliance, is not going to develop any specifications. Then the next question is, okay, the other working groups we do envision will continue to develop specifications. And then, as you can see, right now, as you pointed out, there's already a 5G architecture, and the specifications that have been developed, either they're kind of like where the interfaces exist in the architecture, they're the same, right? But where they're missing, or there can be more disaggregation and so on, then they're adding some specifications. And that is the model that I was talking about. So now, when architecture discussions happen in 3GPP, for instance, if there are more interfaces that are defined, as long as they kind of are following the principles that ORAN Alliance is trying to drive, then it's well and good. But if there are aspects that the industry sees are missing in what is being done, then I would envision very much that the ORAN Alliance will continue to do what it's doing today, to provide the additional interfaces in order to make the architecture...
Or even alert the 3GPP group sooner so that the architecture can be...
Yeah, so another part of this is...
being retroactive, as you know.
Yeah, but another part of this I want to address also. I think in the nGRG, what we are trying to do is I mean, you described it as a discussion club. Yes, I mean, any one of these research forums, before we get to standards, are discussion clubs. But having said that, I would say each of these is important in the sense that if we, for example, identify in the nGRG that there are some aspects that might be missing in the current thinking pushing towards standards, then pretty much all of these same companies that are involved here are also involved. I mean, these are not like separate, although we talk about them as separate bodies, we are all the same, companies that are. So those learnings we very much expect to translate into what is being proposed elsewhere. Because in the end, it's not just about a single global standard. I mean, we want that to drive an architecture that is coherent and not like kind of divergent, right? So the architecture, and that architecture in a way is defined not actually only in one body, and that was the point I was trying to make. So there will be an impact, we hope, in what we do in nGRG. It's just a question of how direct or indirect it will be. Yeah.
That makes more sense. So can I have a quick follow-up question, slightly separately, since I'm still holding it?
Okay.
Your comment as well, I don't know if it's a comment in passing, but you said I'd make sure it's cloud native or adheres to cloud native principles or something. I just wonder if that's a sort of an assumption that's too soon to make. Like what we think of as cloud native is not one, should we even be making that assumption? I mean, I think there's definitely a view in the operator community that 3GPP shouldn't have made the service-based architecture it was almost defined as being deployable on software-defined infrastructure. I think a lot of people now feel that was a mistake. Your comment might have been throwaway, or is it? I just wanted to hear about that as well. Is it a dangerous assumption to say it's going to be cloud native at this point? Because
maybe because I made the comment, I can start, and maybe you can add some. Yeah. So. Yes, I mean, like, for example, in the research item that has kind of the one area of activity that has been started in this architecture research stream within the nGRG, I mean, maybe rather than cloud native, it's a cloud-friendly architecture. How do we create a cloud-friendly architecture is how they have kind of characterized it, right? So I think, yes, I mean, at this point, there is, of course, a big assumption amongst many companies, as far as I understand, that we need to have things be cloud native. But that doesn't necessarily mean, to my understanding, that we cannot improve on aspects that we feel have been missing or overemphasized, let's say. Another thing I would also say is that you're certainly right that one thing I would expect going forward with 6G, and already with 5G we see the trend that the deployments have become more heterogeneous in the sense that there are more frequency bands, we have more vertical use cases we are trying to address. So all the way from the use case dimension to the deployment and to what we put out on the air, there is a much more diversity. And if anything in 6G, that will only become even so, right? So the architectural challenges are quite extensive, and so that is why I think one big thing that we were trying to emphasize here, it's not so much that we hang on only one term, like it's either cloud native or it's embedded or something, but I think flexibility is really, really important. And to some extent, I would say one thing the O-RAN Alliance has been kind of driving, even with all of these disaggregation stories, how to kind of have adaptability, right? And that is in the end what all of the customers really want. So that would be my thought on that.
thank you.
I do want to chime in a little bit. I mean, at the end of the day, right, whether it's cloud native, cloud friendly, I mean, the key principle here is, we're moving towards more, as you said, softwareization. Virtualization is a key pillar, one of the 4 of the mission for O-RAN. And I don't see us, I mean, I think there is consensus that that's the direction we want to go. We're not saying, oh, we're going to turn back and start, everything should be ASIC based again, right? I think, we're at this journey, we're at this trajectory towards 5G. I think maybe I don't want to speak for everybody, but at least my impression and my understanding is we're not, if anything, we're moving more quickly towards that rather than away from it.
Any other questions from the audience? If not, maybe one question I could ask the panel before we run out of time here. I think we are talking about architecture, right? And we all recognize that architecture is really important and crucial, and we also talked about how it needs to be kind of flexible and adaptable. But maybe staying then on this topic, I mean, clearly, I mean, the O-RAN Alliance has had quite a bit of impact on how the entire industry thinks about the architecture, right? But maybe I can get your thoughts on how do we see this going forward in terms of those impacts? I mean, are we at a point where the kind of things we are talking about right now, do we think are enough in the 6G timeframe? Or do we think that there will be some things we need to maybe do differently than what we are doing now, back off from some of these trends, or maybe accelerate some of these trends? Any kind of thoughts on what we might end up in 6G? And especially, I would also add in the context of AI becoming quite important in various levels. So just as a question, I mean, if we make the architecture kind of very friendly towards applying AI ML techniques in various parts for optimization, then we could have, maybe a lot of benefit from that. On the other hand, we have some trade-offs in terms of maybe security and so on. But how do we make the architecture in the world when AI is really going to permeate and accelerate? What do we think the impacts will be for us?
So it looks like a challenge question.
It's a difficult question.
Yeah. So in my opinion, that at least this AI stuff is ongoing, right? For put into the architecture, even 3GPP deal with AI and in the low layers that run 1 and also run 3, and for this nGRG, for the AI topics, at least we're trying to go a little bit beyond that current what we're doing in the all-round working group, because the deal with this AI is at least in the non-real-time RIC side. So in some sense that this research group, we try to investigate how AI should adapt to the architecture, but we don't deal with the architecture, how to provide the solution itself. So I think at least some answers may give insight on how we should drive in this, not only all run in 6G, but also in general. So in 6G and how, for instance, AI should be how to say, be put into the place in the how to get a support interface and how to support AI from an architectural point of view. So it's still, I think, the early stage, and we see how the answer will be and what can impact really will influence the final outcome of the architecture.
Any other thoughts?
Yeah, I mean, just there's always, I mean, human nature, there's a tendency to swing the pendulum one way, and then if it doesn't work, you swing it a little bit too much the other way. I mean, clearly with things like AI and ML, we're seeing a lot of hype going into it, and I think we still need to be very careful. Like there are aspects that, AI, ML is a tool. At the end of the day, it's a tool that's applicable to certain problems, and a lot of problems, if there's a lot of data, you can really leverage it. And I do think that maybe there are some aspects that, maybe AI is not the best, but you still see it being applied left and right just because a lot of academics here, that's what gets the grants, right? So I think we just need to be careful and say, it starts from good data. We need to have accessibility to that data and really come up with architectures that, again, we should be intelligent about how we use intelligence.
Yeah.
Yeah.
Chen, go ahead.
Yeah, from China Mobile's perspective, we think that the openness is the most important issue of the 6G network. For operators, we have benefit from the in the 5G network, we benefit from the cost, skill, and for the global roaming, and all based on the openness. So the 6G network, the openness is most important. And to achieve the openness, we think that first we need an open architecture. And that's the view from the operator. Yeah.
Okay, good. So I think we had a little bit of a late start, but maybe if I can, just for a couple of minutes, ask one more question just to, so I think maybe a more concrete question for what we are discussing here, or to frame it a different way. So right now, I think in the ORAN architecture, for example, we have a lot of these, we have control loops with different time scales, right? So we have something with a bigger time scale and a smaller one, and an even tighter control loop. I guess a key question for us is whether that framework is good enough, or do we need to add control loops and even finer time scales and build an architecture around that. But I don't necessarily have an answer to it, but I don't know if you, in the last maybe 1 minute, if any of you has any thoughts on that, we could maybe sum up.
I mean, just quickly, I mean, we talked a lot about, I mean, definitely a lot of academic research right now on concepts like DApps. And at the end of the day, I guess we have non-real time, near real time, and maybe a real-time RIC, right? or some other aspect, or maybe all these RICs are really, it should be just one big conglomerate, right, of really understanding how intelligence can be applied across the entire stacks of the network. I think the jury is still out there. I mean, at the end of the day, we need, AI is all about, accessibility to data and interfaces that can be opened up so that you can actually do both the sensing and actuation of the network, right? I mean, without those, this is all just a pipe dream. So I think it starts with, whether, vendors, operators can come together and agree on opening up those interfaces and, sharing that data.
Okay, good.
Yeah.
Go ahead.
But I think already the country loops go down to the low layers, and even they need some very low country loops. I mean, for instance, this beamforming and stuff, and they need to put into the RU, and this happen, and also up to the management layer, and even if you say this cross domain, and you need to coordinate all the, not only this computation resource, but also the communication resource, and then you may need another loop there, right? So I think this is open question, and you need more investigation for that.
Jejin?
I think from the operator, we just set up the target, and we also made some analysis. We found that no matter the architecture or the other technical specs, we think that there should be more interdisciplinary technology in this area. For the 6G network, it will bring more complexity. For operators, we have already the legacy networks. So we think that for the 6G network, the simplified network should be important. And if you want to solve this problem, the complexity, we think that there should be some interdisciplinary technology to bring to the 6G network. Mm-hmm.
Thanks. So I think with that, it's time to wrap up. And so I thank my fellow speakers and panelists here for the session. Hopefully you got something out of it, and you know something about what we are doing here in the nGRG. One thing as a closing remark I would say is that we very much welcome participation. So if if you think there are directions we should explore, for the benefit of the industry, then your contributions are most welcome. So thank you. Thanks once again.